Today we're exploring one of the most important concepts in instrumentation and doing one fun IOAA question, which is a really interesting one. We all know about Snell's law, we all know about F number as it is focal length divided by diameter. We all know the Snell's law sin theta 1 by sin theta 2 because this one right here. We all know magnification, we all know this is this. Let's talk about area disk. This is a diffraction pattern caused by light passing through a circular aperture when it is best for this. So angular diameter of the area disk is this. So CCD is just about CCD. We have theta equals S by F, where S is the longest separation and F is the focal length. Let's go to one crazy question. I guess I have one interesting question from the national round. Really easy one. Okay, this is the question. Consider the boundary between the two atmospheric layers of refractive indices N1 and N2, eta 1 and eta 2, to treat an angle. This is this, it's on this, zenith this. So we are advised to draw a well labeled diagram for this. So right now here we know this is the horizontal while this is the tilt. Light is coming from the zenith. Now what we have is normal. We have a normal, we have theta equals 30 degrees, and we have a rarer medium and a denser medium, right? So now what we are going to do is make a good analogy of what's happening. This is the horizontal. Now I'm going to make this, which is the tilt, which is theta equals 30 degrees. Also, let's make I guess a dotted line, which is the normal right here. And also I guess we need to make the right. Okay, not going as what. Yes, anyways, this is the undeviated path. Undeviated path, right? When the light ray enters from the zenith, we have a certain deflection, and we call this deflection the alpha. Thus this will be theta minus alpha. We know this is as given in the question n2 and this is n1. Fine. What we have been given, this is extracted from IOAA 2025. We need to find the expression of alpha in terms of theta, n1 and n2. So now we need to find the expression of alpha. We know sine theta 1 divided by sine theta 2. For a fact, we know this is also going to be theta, okay? Sin theta by theta minus alpha. This is the normal right here. It's going to be n1 divided by n2 as per the figure. So to eta sine theta equals eta 2 sine theta equals eta 1 sine theta minus alpha, or eta 2 sine theta equals eta 1 sine a cos b minus cos a sine b, or eta 2 sine theta equals right. For each small angle approximation, sin alpha is alpha, cos alpha is 1. Therefore, sin theta minus alpha cos theta, we have that right here. n2 sin theta equals n1 sin theta minus n1 alpha cos theta. So n2 sin theta minus n1 sin theta minus n1 alpha cos theta, or sin theta minus n1 divided by cos theta alpha minus n2 equals alpha. Oh, I guess, and then divided by n1, or tan theta 1 minus n2 by n1 is going to be. So this is the answer. This is just the question. This is the question extracted from IOAA 2025. We will do other questions as well, which are from here. Those are just easy questions, I guess. These are just easy questions. Easy. I don't think this needs any. This is also easy question. Let's not care about it. Okay, that was one IOA question right there. Now, talking about lengths. Now we're going to talk about lengths, while we are going to talk about the Cartesian convention. We have the rule of everything. Right is positive, left is negative, down is negative, up is positive. So for a convex lens, we have u is smaller than 0 always. Object is placed on the left, and like usually and real image, because convex lens forms the real image, which is on the right. Convex lens, we have the focal length as positive, because focus is formed on the right. So for a real image, we have u equals negative, v equals positive, and f equals positive. Since we have this convex lens right here, light ray falls and just goes from there, focus is right here. Therefore, u is always real image is formed in the convex lens. Therefore, v is greater than 0. This is going to be the real image. F is greater than 0 for the convex lens. So yeah, this is it. So plus v tells the image is on the right. So for a convex lens, concave lens, for a concave lens, we have focal length as negative, because for a concave lens it just forms the things right here. Focal length is going to be negative, u is going to be negative for of course reasons, that v, which is also going to be negative because image is going to be formed here, which is virtual. So for a mirror, now for a mirror, let's say the concave mirror, where this is somehow a concave mirror, this is the focal length C, F, this is all going to be negative. So inverted image, v equals negative, F equals negative, u equals negative. Why is v negative? Because image distance is on the left, object is on the left, image distance is also on the left. So concave mirror is just that. So about the convex mirror, we have this, right? Now we have the object right here, u is smaller than 0. We have the focus behind the mirror, so f is greater than 0. Then image is also formed behind the mirror, which is v is greater than 0, which is still the visual image, but it's formed behind the mirror. Here also we did have the virtual image is formed right here. In case of convex mirror, is literally formed right here, therefore the image is greater than 0. Now again, for this is not a virtual image, this is a real image, and real image is formed on the right by the actual intersection, therefore it is greater than 0. Many people have confusion right there. So if you want to make the master table with the optical device and u, v and f, then convex lens, convex, concave, convex and concave, again lens, mirror, u is typically always negative. So see, for a convex lens, image is going to be real, right? But it is going to be formed, as I've shown you here, is going to form behind the mirror, therefore image must be positive, it's a real image, right? So focal length is also positive. Concave lens, which is, as you see right here, concave lens has a focus which is right here, left in front of the mirror, therefore we have focal length negative, we have object negative, and it is found right here, therefore it is also negative. I hope you are understanding this. Wherever the focal length, wherever the focus, there the image is formed. You need to know that. So for a concave lens, we have negative. For this we have negative for real image, positive, virtual, negative, negative, positive. This is it about the optical devices, because I might want you to give one thought about this convex lens, image is formed right here, focal length positive, image distance positive, u negative. Concave lens, image is formed right here, focal length is right here, object is right here, all negative. For a convex mirror, which is this, which is, wait, what, I'm sorry, for a convex mirror, which is just like this, we have, wait, yeah, so for convex mirror we have the image being formed right, and then focal length is also on the right, I mean the focal, this one. For a convex mirror we have focal point on the right, we have object on the left, image on the right, just like it. And for a concave mirror the same thing applies, we have focal length in that on the very left, and we have this master table. I hope we don't have any confusions for that. And for magnification, for a mirror it is minus p by u, while for a lens it is v divided by u. I guess this is it for today. I'm not going to do a lot of things. Angular resolution, we know about the resolving power, which is just d by lambda. We know about this diffraction limit. Diffraction is just a spreading of the wave when it passes through an opening or around an obstacle. We know about brightest spot, we know about area disk, we know about a pattern. I guess this is it for today. Thank you.